Alright, introduction to treatment of steam boiler water. Alright, steam boiler systems, boiler water treatment and control, developing steam boiler system water treatment program, chemical requirements for boiler startup, chemical requirements for boiler layup, commonly asked questions, answers on boiler water treatment. This publication is adapted to unified facility criteria. Government public domain have been authorized for unlimited distributed and are not copyrighted. Alright, steam boiler system. Steam boiler system defined. The steam boiler is enclosed with a vessel with a hole with the water with a heat with the external source of the conversion of the water to steam. All steam boilers contain tubes that separate the water with the heat source. Steam boilers are described in the publication. Type of steam boilers. Boilers are classified in two criteria. Operating pressure, the amount of the internal pressure generated of steam is produced. Two, the operational design, where the water and water tube boiler or heat source of fire tube boiler passes through the inside of the tube of the vessels. Pressure classification. Boiler operates pressures below 103 degree kilopascals or 15 pounds per square inch are defined as a low pressure boiler. A boiler operating greater than 15 pounds per square inch is defined as a high pressure boiler. High pressure boilers can operate with a pressure reaching thousands of kilopascals or 1,000 pounds per square inch in gauge. Fire tube boilers. Fire tube boilers pass fire and hot combustion gases through interior boiler tubes. Heat water surrounding tubes. See the type of the boiler design commonly used with the factory assembled package boilers, which are low pressure. Water tube boilers. Water tube boilers pass water through boiler with a fire and combustion gases contacting exterior tubes. Water tube boilers are used in the high pressure, very high pressure application, more military installation, central boiler plant containing water tube boilers in addition with fire tube boilers located in service of individual buildings. And it shows a heat and gas combustion. The fire tube heater is inside of the tube in fire figure 1-1. And water tube boiler, the flow, the feed water, steam, and the heat. Boiler capacitator rating. Boiler capacitator rating is given as a unit either with a boiler horsepower, kilograms steam per second, or kilowatts, or BTU hours per hour. Specifically, one boiler per hour, one boiler horsepower unit reflects energy converted with a 15.7 kilograms to 34.5 pounds of water to steam at 100 degrees Celsius at sea level, the equivalent of 33,459 BTUs per hour, 9.812 kilowatts. 2 kilograms steam produced per second. Pound of steam produced per hour represents the number of the kilograms of the water each of the second per pound per hour to produce steam. 3 kilowatts or 3,413 BTUs per hour reflected energy needed to evaporate water, produce steam each hour. But the actual quantity of the steam produced will vary depending on the boiler efficiency, boiler operating pressure, altitude, the respective sea level. Components of the steam boiler system. The function component of the steam boiler system vary from one system to another based on the variety of the design, engineering, surface requirement. The typical components they would include with the specific unit illustrated in Figure 1-3 with the briefly described in paragraphs 1.121 and 1.225. And it shows a component simple steam boiler system, which is a little bit too hard to read. Pre-boiler. Pre-boiler section steam boiler with the encompassing of the boiler system with the structural component with the hold on move of the treatment of the treat the water before the water enters the boiler. Pre-boiler system component with include with the integrated supplementary water pre-treatment equipment that use the process of the boiler water makeup water. The aerator used to remove the oxygen of the non-condensable gases. The feed water heaters and pump of the pre-boiler section may include the short tank of the treated backup makeup of the water boiler feeder is usually composed of the makeup water combined with the condensed steam with the condensate with a return with the distribution system they call with the condensate return. The feed water preheated not an inch of the aerator which remove the aerator oxygen or volatile gases. After boiler, post boiler section of the boiler system encompassing structural components of the boiler system that hold or move the process of the steam water downstream for the actual boiler. After the boiler includes the steam pipe and the heat exchange with the steam trap, the condensated pipe and the turbine with the produced equipment and superheater. Boiler components. The fire tube passes through the hot combustion gas through the tube with the water surrounded with the water converted with the steam. The water of the tube boiler passes the hot combustion gas around the tube which contain the water to be converted into steam. In the event of either the type of the boiler with the steam passes into the steam drum with the ends of the steam lines. Circulation of water into the water tube boiler may be accomplished by heating only with the process of the natural circulation, which requires no external force or pumping. Alternatively, the water can be pumped through the heating circuit of the boiler by processing referred to as forced circulation. Usually a metal mud drum is provided with the lowest point of the water circulation section to allow the removal of any water form sludge. This will be at least 2 locations removal of the boiler water blowdown. The surface blowdown, sometimes referred to as a skimmer, located below the operating water level of the steam drum. 2, 1 or more bottom blowdown location of the mud drum. Steam drum. The feed water is added to the steam drum with a mixture of the steam and the water produced with the wear. The steam is separated from the water with the separation process that usually include with the mechanical devices to sift the removing any of the trained boiled water in from the steam. Chemical used in internal boiler water treatment may be added to the edge of the water steam drum of the process, either the continuous and intermittent surface blowdown with the use to maintain TDS or of the boiler water, achieving the optimum operational condition for the boiler and some boiler system blowdown. Water will be discharged flash tank with a low pressure setting steam that produces the possibility of the deaerator as all water continues blowdown may be preheat. The makeup of the water making means of the heat exchange of steam from the drum may be discharged directly with the steam header, but some boilers are heated further in superheater generated superheated steam. Steam header. The steam generated with the boiler discharge from the steam header drum to header of the steam header feeds for the steam to the steam distribution system. Steam consumed through the process. Equipment lost through the leaks lost through from valve fittings of the steam and traps and condense for the return of the deaerator. Subsequent retrieve reduce additional steam production. Measuring equipment developed and appropriate with the water treatment program the steam boiler system as well with the minor effectiveness ongoing program measure for the quantity of the feed blow down wake up condensating into this from the system minimum install flow meter with the make up the water line install the flow meter on the feed water line and steam header is also advisable but due to cost consideration practice as usually limited to the large steam boiler with the rate of the volume of the production condensate with the blowdown water can be calculated using the methods described below. Common boiler problems. Common water-related problems inside of the entire boiler system, corrosion, deposition, and carryover. Corrosion problem. Corrosion problems result of the action of the oxygen effect of the low-high pH metal components, including the boiler tube, the drum of which are constructed of the carbon steel of the corrosion can also occur with the excessive alkalinity with excessive pH of the boiler water causing attack and most likely to occur with the underscale of the deposit. Very high level of the concentration of hydroxide and can be over the zone with the sufficient cooling flows fail sufficiently to remove the heat of the input leading to the boiling. Thus, steam blink and occur with corrosion can occur in boiler as well within the pre-boiler, after-boiler section, which can also construct with the carbon steel of the corrosion the result of the loss of metal volume in a reduction integrity of the metal situation that can be led with the structural failure, particularly with the metal loss localized. Corrosion, therefore, as a safety concern, corrosion in steam lines and condensate lines located in the after-boiler section and carbon steel piping that can result in the production of steam system leaks leading to the loss of the condensation situation, which increases the demands of the energy with the chemicals. And this show, figure 1-4 shows boiler tube oxygen pitting. Deposition problem. The deposition problem resolve with the precipitation minerals dissolve with the feed water causing the formulation of 1 or more 2 scale of the boiler system components. Deposition can occur with the mechanism of the corrosion product with the rust engine of the boiler before and created with either the after the boiler pre-boiler section. Corrosion products can either form iron-based scale with using certain of the water treatment chemicals to resolve with the formulation of the scale of the when chemicals are not properly applied. All scales provide insulation with the transfer of the heat between the water and heated metal tubes. Scale can occur with any section of the boiler system resolve with the reduced capacity of the heat transfer due to the resulting reduced heat transfer of the fire side of the tube water with the metal tubes can operate with a higher temperature for the scale with providing the insulation from the contents. Consequently, the steam produced with the greater the fuel demand. Fuel costs are increased with the greater the thickness of the scale, with the greater the insulating effect, with the higher the temperature of the tube, with the sufficient and high metal temperatures. Tube can lose in the tensile strength and rupture. Figure 1-6. 1-5 shows the scaled boiler tube. And then 1-6 shows your impact scale on transfer with the tube metal temperature deposit thicknesses. Figure 1-7 the metal to fatigue on the boiler tube, and then figure 1-8 shows a failed boiler tube. Alright, 1-1-4-3 carryover problems. Carryover problems are called for the misting of the foaming of the priming of the silica, carryover of the process of the result of the impure steam, called for the dissolved solid contained with the carryover of the material that can be attributed with the corrosion of the deposit problems. Calculation. Understand with the use of efficient boiler operation of the boiler calculation performed with the result of applied correctly with the boiler calculation or mean with the provided information to determine the optimum blowdown rates to assess the condensation return with the given efficiency of the blow operation can be achieved with the optimizing COC with the adjusting of the amount of the blowdown to give it the proper volume of the water Efficient blower operation to govern return with the most condensate with the possible material balance of the mass balance of the operating boiler system can be calculated for the result of the water test known as the measured value of the signal boiler operating parameter of the steam production makeup of water used as feed water used in the air or blowdown steam table that can be used with the mass balance. Mass balance is the information from the calculated energy input with the energy output of the boiler system chemical feed rate with the mass balance. The information developed an estimation tool for annual consumption of the water treatment chemical for the familiarity with the calculation procedure for the application of the boiler system operates assessment is required of any base of the facility engineer section supervised for the knowledge useful for the boiler operators. 1151 cycles of concentration. Cycles of concentration steam boiler term that refer to the number of time of the mineral feed water have been concentrated within the boiler by its operation. The boiler is evaporated steam of the produced with the mineral that dissolve of the boiler water with the remaining behind with the increase of the mineral content of the remaining water. Steam is produced with the address additional mineral laden feed water entry enter the boiler resulting in additional minerals being added introduced the boiler increasing the amount present in the water boiler mineral content in operation. Boiler water system can be limited only by blowdown, and COC is for cycle of concentration. Blowdown. Blowdown consists of the draining some of the boiler water accumulated solids with the replacement of the treated feed water with the before full levels of the sodium reach. I dissolve sodium with a ton to concentrate with the near the water surface of the sealed drum, and then therefore the surface of blowdown is most effective with reducing the concentrate with the dissolved solids. Bottom blowdown is used to remove the precipitated sludge of the boiler mud drum. However, the blowdown result of the loss of heat of the water treatment chemicals. Economical operation requires careful control of the blowdown. Maintain sage solids at the level of minimizing both heat and chemical additive loss. Water balance feed water evaporation and blowdown. Total volume of the feed water have of the boiler must equal to the total volume of the water plus steam plus the boiler water blowdown that is removed from the boiler. By convention, these waters equivalent quantities are commonly expressed in kilograms per second or pounds per hour in the equation for the water balance below. F is the feed water is equal to the steam generated in kilograms per second or pounds per hour plus blowdown per pounds per hour. Calculation of feed water blowdown water. Feed water blowdown water can be calculated in relation to the cycle on concentration using these equations. Cycle of concentration, no units is equal to the feed water and blowdown per hour divided by blowdown by pounds per hour, or feed water is equal to the blowdown pounds per hour times the cycle of concentration, no units, or the blowdown pounds per hour is equal to feed water divided by the cycle of concentration. It's commonly expressed blowdown percentage equals the percentage of blowdown is equal to 100 over the cycles of concentration units. Relationship between the feeder blowdown steam generation with the cycle of the concentration. Even the terms above with the relationship between the feed water blowdown steam generation cycle with the concentration represented, and then shows these equations, and then calculation blowdown rates. The blowdown rate of the water volume, rarely measured by a meter, is shown below by the calculating the two volume of the parameters known as the feed water with the cycle of concentration, steam generation, and steam volume. They usually measure the units meters large boilers. Cycle and concentration can be used with the calculated measurement conductivity of the TDS and both water boiler water and feed water. Note that the conductivity quality of the TDS is the same as the boiler water and blowdown matter. Cycle of concentration is equal to the blowdown TDS parts per million equal to the feed water DDS parts per million or by blowdown concentration micro HOS divided by feed water conductive micro HOS. Determine the water feed water blowdown rates. Blowdown calculation paragraph 1156 with the determine the feed water with the rates using with the kilograms per hour with the pounds per hour with the note with the feed water referred to the water with the referred to the boiler include the makeup of the water with the condensate with the return of the steam from the exterior aerator. 250 pounds per square inch boiler operated with a conductivity level of 5,000 UMs and a HOS. And boiler feed water has conductivity of 250 UM HOS. Cycle of concentration calculation is the COS blowdown over the feed water, and then percent blowdown is equal to percentage of blowdown over 100 cycle of concentration, or 100 divided by 20 equal to 5%. Boiler produces 5 kilograms per second of steam. The blowdown is equal to the E divided by the cycle of concentration A, or 5.0 Feed water is calculated by feed water M E N plus B is equal, and this is equivalent to 5.3 liters per second, and illustrating figure 1.9. Figure 1.9. Simplified boiler system water balance, and it's are determined to make up of the condensate with the rate of the return of the makeup of the boiler with the external water. Treatment the system with the head with the boiler with the bottom system upstream with the de-air with the amount with the corrupt with the volume percent with the makeup of the boiler with the required with the boiler effective with the blowdown steam leak consumption with the steam with the process with the equipment the lowest with the condensate with the boiler system leak with the tab with the boiler system with the system and not lost with the precursor with the equipment about with the 5 to 10% with the makeup with the expect with the water balance effective with the condensate with the return half with the boiler is lost with the considerable dense. Due to the loss of the steam of the condensate, but it can approach the requirements of the 100% of the makeup of the very efficient with the cost of the condition, the calculations below with the be to determine the makeup of the water with the need of the condensate with the return lines. Makeup of the water return line. Makeup of the difference with the both between the volume of the condensate with the return of the volume of the feed water and the makeup of the pounds per hour equals feed water in pounds per hour minus the condensate return in pounds per hour. The condensate with the return the return condensate usually does not contain the appreciable level of the dissolved solid of the conductivity of the determination of the percent makeup that's calculated using the equation. The percent of the makeup is equal to 1 minus the feed water conductivity micro micro UHMOs divided by makeup of the conductivity micro MHOs times 100%. And then they give the example, and then the difference between the amount of the steam produced with the amount of the condensate, with the difference between the amount of the steam produced with the amount of the condensate, with the return represented with the combined loss of the system of the bowl system and the condensate with these loss with the result of the leakage system, steam consumption of the steam of the process of equipment, the leak of the condensate with the deliberately with the discharge of the condensate with the contaminated condensate with the total loss of the loss could be calculated. So total steam condensating loss for the pounds per hour is equal to the stored and steam generated minus the recondensated return, and then show for the example the basis of the evaluation of the boiler system efficiency. A good base for the evaluating boiler system efficiency for the development of the monitoring of the system, some water for the conductivity value for the measuring quantity of the steam generated, with the performance of the required calculation for the regular schedule, with the interval of time, increase for the steam loss, with the maybe to indicate with the new leak over the side, with the increase for the existing leak, for the new consumption with the steam, with the condensate with the loss, with the additional calculation. Boiler system efficiency can be provided with a good base for the estimating saving the steam costs resulting from maintenance efforts to reduce the steam and the condensate losses. Boiler water treatment control. Cut the tape there.